To continue some of the examples, we're going to have a free fall with an initial velocity. You throw a ball up into the air at 25 meters per second. How high will the ball go? Let's start with some information that we know. We know the initial velocity, that's going to be 25 meters per second. We know the acceleration. Anything that's falling is going to have an acceleration of negative 9.8 meters per second squared. We also know the final velocity. When it gets all the way to the top of its path, it's going to stop before it comes back down. So we know the final velocity is going to be equal to 0 meters per second. What we're looking for is displacement. We're looking for a vertical displacement. So the equation we're going to use for final velocity, initial velocity, acceleration, and displacement is going to be final velocity squared. That's going to be equal to initial velocity squared plus 2 times acceleration times displacement. We're going to plug in the numbers that we know. That's going to be 0 squared, that equals 25 squared, plus 2 times negative 9.8 times the displacement. We get 0 equals 25 minus 19.6 times displacement. Subtract 625 from both sides, and then divide by negative 19.6, and that gives us a height of 31.9 meters. Now, we're using the same example. The question here is going to be how long will it take for the ball to come back down from the top? Alright, so we know the initial velocity. The initial velocity at the top is going to be 0. Now we know that the initial velocity was 25 when you threw it upward, but we're not timing from there. We're timing from the top of the path, which was an initial velocity of 0 meters per second. We also know the acceleration. The acceleration is negative 9.8 meters per second squared. The displacement. Now the displacement is a calculated answer. It was 31.9 in the previous problem, but since we calculate it, we really shouldn't use it. However, in this problem, we have no choice. So we're going to use negative 31.9 because the displacement from the top down to the bottom is downward, so it's going to be a negative, and we're going to be looking for time. So the equation that has displacement, acceleration, velocity, initial, and time is going to be displacement equals 1/2 times acceleration times time squared plus the initial velocity times time. Plug in the numbers we know. Negative 31.9 is going to be equal to 1/2 times negative 9.8 times time squared plus the initial velocity, which is 0 times time. That part cancels out, the 0 times time. And we're left with negative 31 is going to be equal to negative 4.9. So we're going to divide both sides by negative 4.9 and we get 6.51. So time squared equals 6.51, square root both sides. And we get the time is going to be equal to technically plus and minus. There are two answers, but we're dealing with future time, so it's going to be positive 2.55 seconds. The next example says how fast is the ball moving when it comes back down to you? Now hopefully we realize that since the acceleration is a constant negative 9.8 meters per second squared, then as the ball goes upward it's going to be losing 9.8 meters per second every second. But when it comes back down it takes the same amount of time, which means it's going to be gaining that 9.8 meters per second back every second that it falls. So it starts out at 25 and it loses 9.8 every second that it goes up until it's 0, and then when it comes back down it gains 9.8 meters per second every second. So hopefully it's not too much of a stretch to realize that the velocity when it comes back down is going to be the same, but in the opposite direction. So we start out at positive 25 meters per second. Hopefully we end at a negative 25 meters per second. But let's actually calculate it. We know the initial velocity when it goes upward, it's positive 25 meters per second. We know the acceleration. That's going to be equal to negative 9.8 meters per second squared. We also know the displacement. Now think about this. It's going to go up and it comes back down, so we think the displacement, well, is upward than the downward. But remember, displacement is final minus initial. If it starts at the height that you throw it from and then ends at that same height, then the total displacement is going to be equal to 0. So how fast is it moving when it comes back to you? That's what we're going to be looking for. So which equation has initial velocity, final velocity, displacement, and acceleration in it? We're going to use final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. Let's plug in the numbers that we know. The initial velocity is 25, acceleration is negative 9.8, and the displacement is going to be 0. So that whole term cancels out, and we're left with final velocity squared is going to be equal to 625. Square root both sides, and we actually get two answers from this. The final velocity is going to be plus or minus 25 meters per second. Now the positive 25 meters per second, why do we get two answers? Well, positive 25 meters per second was at the beginning, right? So so we get two answers. So the question is, was the initial velocity 25 meters per second for that positive 25? Yes, it was. Was the acceleration negative 9.8 at the beginning? Yes, it was. Was the displacement 0 at the beginning? Yeah, it was. But we're not really concerned about that because if you think about this, this is a parabola. It goes up and comes back down. So we're more interested in the negative answer. The final velocity is going to be negative 25 meters per second. So it goes upward and then comes downward, and then the final velocity when it's coming back downward is negative. The question here is how much time does it take to do the total trip? From beginning to end, we know the initial velocity at the beginning is positive 25 meters per second. We know the acceleration is negative 9.8 meters per second squared. And if you remember the displacement, since it starts and ends at the same height, then that's going to be 0 meters. How much time is going to pass by? We're going to use the equation displacement equals 1/2 times acceleration times time squared plus the initial velocity times time. We're going to plug in the numbers we know. 0 is going to be equal to 1/2 times negative 9.8 times time squared plus 25 times time. Clean that up a little bit, and you get 0 is going to be equal to negative 4.9 t squared plus 25 times time. Now hopefully you notice in here we have a common factor. We have t that we can pull out of both of these terms, and we get that t times negative 4.9 t plus 25 is going to be equal to 0. Now when you got two numbers that multiply together to give you 0, then that means either one or the other of those numbers equals 0. So let's split it up. T is going to be equal to 0 seconds. Now, does that actually mean anything? T equals 0 seconds. Well, at 0 seconds, was the initial velocity 25 meters per second? At the beginning? Yeah. Was the acceleration negative 9.8 meters per second squared? Of course it was. Displacement at the beginning, was it 0 meters? Yes, it was. So we get that time equals 0 seconds, but that's not the time we're concerned about. We're considering the other side of the parabola. We're getting negative 4.9 t plus 25. So we're going to subtract 25 from both sides. Then we're going to divide by negative 4.9, and we get a total time of 5.1 seconds. Now hopefully that makes sense, because from the top to come down it was 2.55 seconds. So the entire trip should be twice as much, which is 5.1 seconds. Now what does the position versus time graph and velocity versus time graph look like for these examples? Well, in order to draw a position versus time graph, we have to know several things. We have to know where the position is at certain times. Well, at the beginning, we know that there is 0 displacement at 0 time. So we got that point. In the middle, we know that at 2.55 seconds, it was at a position of 31.9 meters. At the end, it comes back down to where we started, so we know the final position is 0 at 5.1 seconds. Make the entire parabola between those 3 points, and that gives us the position versus time graph. Now what does the velocity look like? Well, again, we need some points. At 0 seconds, we knew that the initial velocity was 25 meters per second. At 2.55 seconds, when it's at the top of its path, we know it stops, so it has 0 meters per second. Also, when it comes back down to the same position when what it started, we know that the velocity is negative 25 meters per second, and that's at 5.1 seconds. Now this should look like a straight line because velocity versus time graph with constant acceleration is going to be a linear graph. Now the question is, what's the slope? Well, hopefully you realize the derivative or slope of a velocity versus time graph gives us acceleration. Well, what's been the acceleration we've been using the entire time? Negative 9.8 meters per second squared. And if you want to, you can calculate it. 25, we go down 25 and over 2.55. So if we take negative 25 divided by 2.55, we get a slope of negative 9.8 meters per second squared, which is the acceleration we've been using the entire time. In this problem, your angry girl/boyfriend, depending on who you are, throws your keys off of a cliff with an upward velocity of 15 meters per second. How long will it take for the keys to hit the bottom of the cliff, which is 35 meters below? Alright, so we start out with the information we know. Since we have a velocity that is upward, we have a positive 15 meters per second initially. We also know that our acceleration, anything that's falling, is going to have an acceleration of negative 9.8 meters per second squared. The displacement, now the displacement looks like it's going to be 35 because that's what we have here. However, we're going to end lower than where we started, so it's going to be negative 35. Now if you think about this, the keys are going to go up and then come back down. So we end lower than where we started. If we do final minus initial, that's 0 minus 35, that gives us negative 35 for our displacement. And time is what we're going to be looking for. All right, we're going to use this equation. Displacement is going to be equal to 1/2 times acceleration times time squared plus initial velocity times time. Plug in the information we know. We got negative 35 is going to be equal to 1/2 of negative 9.8 times time squared plus 15 times time. Clean this up a little bit and we get half of negative 9.8, which gives us negative 4.9. And then we're going to add 35 to both sides, and you'll see why in a second. So here we have our equation. 0 equals some term times our variable squared plus another term times our variable plus another term. This kind of looks like a quadratic equation. 0 equals ax squared plus bx plus c. So we're going to use the quadratic formula in order to figure out what the time is. Our variable is time, so time is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in a, b, and c. And we get time is going to be equal to negative 15 plus or minus the square root of 15 squared minus 4 times negative 4.9 times 35 all over 2 times negative 4.9. We crank that out and we get two answers. We get negative 1.55 or we get 4.61. Now which one is correct? This one or this one? Well, if you think about it, the positive answer makes most sense because negative answer just means in the past. So if we look at the entire parabola, 1.55 seconds in the past from where we threw it, that's the other side of the parabola. So that's why we get 2 times, is because we're dealing with two sides of a parabola. So obviously it's going to make sense that 4.61 is going to be our time.